Okay, hey Sheila. So I took the problems that you had questions about, and I put them here the into this document. And so I'm going to walk you through them, or at least part of them. I don't want to give you all of the answers completely necessarily, but hopefully I can give you enough that you can feel like you can get going on them and move forward. So, okay, so this first one, remember that you have to have like terms in order to add radicals together. So right now they're not like terms because this is really square root of 7, this is square root of 49, this is actually the square root of 243, I believe it is, and so on and so forth. So you can't add them together just as it is, but you can simplify. Square root of 7, he's going to stay just as it is, so we'll leave him. Square root of 7 squared, we know that that is the square root of 49, which is just 7, right? Because square root of something squared just comes out as whatever that is. So square root of 7 to the third, we can think of this as the square root of 7 squared times the square root of 7, which becomes 7 times the square root of 7. For 7 to the fourth, again, we've got 7 squared times 7 squared, and we're taking the square root of those. So that becomes 7 times 7, which is 49. So, and then this last one for 7 to the fifth, it's 7 squared times 7 squared times 7. And remember, we're taking the square roots. So this becomes 7 times square root 7, which becomes 49. My 4s are not great, but that becomes 49 times the square root of 7. So now, when I put it all together, I've got square root 7 plus 7 plus 7 square root 7 plus 49 plus 49 square root 7. Now that's not your final answer because there are like terms now that can be combined in order to simplify. So think about how will you combine the like terms and then your final answer. I'll give you a hint. The final answer will be some number plus some number times the square root of 7. So it'll have two terms. In this next one, you have a number, and then you have the cube root of something, and then it's all raised to the third power. So remember that if you have two things that are multiplied together and you raise them to a power, what you end up with is raising both parts to the power, right? So that's a times b to the m power becomes a to the m power times b to the m power. That's called the power of a product rule with our exponents. So here I'm going to have 10 to the third times the cube root of 4x, and I'm going to raise that to the third power. And the cube root of 4x to the third, the cube root and the third cancel, so this becomes 4x. And then you have to figure out, well, what is 10 to the third? Don't leave it as 10 to the third. That's actually just a number. Whatever that number is, multiply it times the 4, and the x, and the x will just be on there. So you'll have, your final answer will be some number here times x. Okay? All right, so on this next one here, so these next several are all about solving equations. And remember that in order to solve equations, you need to get the b by itself. And we're going to use our powers in order to do that. So for this one, I'm going to take this side of my equation and raise it to the third power because that radical is by itself. And I have to do that to the whole other side of the equation as well. I want you to think about what is b minus 3 to the third. Okay? Well, that is b minus 3 times b minus 3 times b minus 3. Or b minus 3 times, when I FOIL or multiply this, I get b squared minus 3b, and a minus 3b becomes minus 6b. It's always challenging when b's and 6's are in the same problem. And then a plus 9. So now I have to multiply through again, and I'm going to get b to the third minus 6b squared plus 9b. And then I have a minus 3b squared plus 18b, and then minus 27. So this whole side of the equation becomes b to the third. When I combine my like terms, I get a minus 6b squared and a minus 3b squared, so minus 9b squared. Then I have a plus 9b and a plus 18b, so that's plus 27b. And then I have a minus 27. This side of the equation, notice I have the cube root, and then I'm raising it to the third power, so the cube root and the third power cancel, so I'm left with b to the third minus 117. In order to solve this, I have to get all of my terms on one side of the equation. So I'm subtracting b to the third, and I'm adding 117. And I'm just trying to line them up where they belong, so that the like terms. My b to the thirds are going to cancel. I have a minus 9b squared plus 27b. And then 117, if I subtract 27, that's going to give me a positive 90. Okay? Now I have a quadratic. In order to solve this, I need to factor out my greatest common factor, which becomes negative 9, b squared minus 3b, and a minus 10. Okay? You need to factor this piece here and solve. You're going to get two different answers. B equals something, B equals something. Don't forget that in order to check that it's true, you have to plug them back into your original equation and make sure that they give you a true statement. If it's not a true statement, then your that possible solution would be considered extraneous. So keep going on that one. Similarly here, I need to square this in order to get rid of my radical, my square root, but I can't do it until till the radicals are at least one of them is by itself. So I need to subtract my square root x from both sides. I think there was a similar one to this on the video I did for this section. So if you haven't checked that out on Moodle, you should definitely do that. Okay. Now I'm going to square. Now on this side, the square root, the square, those cancel. So I have x plus 7. But over here, I have more than just a square root. I have the 7 minus square root of x. Now remember, when we square it, we're multiplying it times itself. So what I get here is 49 minus 7 square root x minus 7 square root x, and then a plus the square root of x squared, because I'm multiplying it by itself. So this becomes 49 minus 14 square root x, and then plus an x. So that's this side of the equation. So 49 minus 14 square root x plus x. I still have a square root, so I'm going to have to square again, but I need to get all this other stuff away from it first. So I'm going to subtract the x, subtract 49, subtract 49, subtract 49, there we go, and subtract x. So then this becomes a negative 42 equals a negative 14 times the square root of x. This canceled, and this is canceled here actually. I could go ahead and square it at this point, but I can still isolate my square root x a little bit more if I divide by the negative 14. Okay, so what you're curious about is how many times does 14 go into 42, and that is 3. And then that's equal to the square root of x. So now I need to go ahead and square both sides of my equation, and I get 9 equals x. Before you know if that's the actual answer or not, you got to plug it back into your original equation, make sure that it gives you a true statement. If not, remember, it would be extraneous. Okay. All right, last couple of problems. Similar process with this guy here. Okay, so we're going to add this square root y plus 6 to both sides. So I end up with 1 plus the square root of y plus 6 equals the square root of y plus 3. Start by squaring both sides. And then it's helpful to have this space over here because I can say, okay, well, what is this when I multiply it times itself? Well, this becomes 1 plus the square root y plus 6 plus the square root of y plus 6. And then I remember I have the square root of y plus 6, and that is squared. That's when I multiplied the last ones together. So this really gives me 1 plus 2 square roots of y plus 6 plus y plus 6, because the square root and the square cancel. Well, if you're simplifying, I would like to write this as 1 plus 7, because the 1 and the 6, plus 2 square roots y plus 6. Okay? That is this side of your equation. Y plus 7 plus 2 square roots of y plus 6. On this side of your equation, the square root, the square cancel, and you get y plus 3. So just like before, I'm going to get that second radical by itself. And I have 2 square root y plus 6 equals, my y's cancel, -4. I think I'm going to leave this to you at this point to continue going, but what you need to do is divide by 2 and then square both sides. Then what you'll be left with is y plus 6 equals some number. So then go ahead and solve for y. Don't forget though, plug that back into your original equation. Check to see if it's extraneous. And lastly, this one is very similar process. This radical is almost by itself, and every other time, like for example this last one, we divided by 2 first. You can do that here, but you're going to end up with some fractions, which will eventually go away, but it's easier to not deal with them at this point. So I would say go ahead and square both sides of the equation here, and see what you come up with. So negative s minus 1, negative s minus 1 gives me s squared plus s plus s plus 1, right? So s squared, that's a plus s plus 1, okay? So s squared plus 2s plus 1. That is this side. On this side of the equation, I have to square this 2, which becomes 4, and then I square the square root of s, 14 minus s, which just becomes 14 minus s. These are still multiplied though, so I need to distribute the 4 times the 14 and the 4 times the s. So this becomes, let's see, 56 minus 4s, and this is s squared plus 2s plus 1. Move this stuff to the other side of your equation, so it's all set equal to 0, then factor and solve. You will get 2 answers here, s equals something, s equals something, and you will need to check both of those to see if it's extraneous. Remember that extraneous solutions make the original equation not true when we plug them in. And they come about because we are squaring things in our equation. Okay? And what is true is that when you square a number, it will always turn positive. Whether it started out as a negative or whether it started out as a positive number, once you square it, the result will be positive. So sometimes that can throw a little wrench in the system and that's why we have to check for extraneous solutions. Okay? So I hope those were helpful. I didn't want to give you the full complete answer on all of them because I want you to continue working them out because that's what's going to help you practice before you end up taking the quiz. So if you have any more questions, go ahead and send me an email. Otherwise, good luck on the quiz. Don't forget you get 2 attempts, and I'm sure you will do absolutely great. So take care.